Everybody, welcome to the lecture on ecosystems, and we're going to specifically focus on forests. We're focusing on forests for a couple reasons. One, we have a lot of fire policy that is around forest and forest management. A lot of our fire prevention strategy also focuses on forests, particularly when we think about debris and underbrush and overgrowth, and how we reduce the severity of forest fires. So we're going to talk about forests today as an ecosystem. So we're going to be using forests as kind of an analogy for the broader ecosystems we're going to talk about. And there's a lot of terms and concepts that we're going to talk about in here that apply across the board. So let's first start with biodiversity. So when we think through biodiversity, we're thinking about multiple levels of where we want to have diversity. So first is genetic diversity. So within a particular species, it's really important to have this genetic diversity. When you have a loss of genetic diversity, you actually have a greater vulnerability to extinction and deformities. You're less adaptable. Negative recessive traits are much more likely to crop up. And this, again, is going to harm the species itself. So the species is a group of individuals that have similar genetic makeups. So humans are a species. We all have different genetics. There's over 8 billion of us, so we have a lot of genetic diversity, but we are a single species. Now, the species level is also where we tend to focus a lot of our conservation efforts. So when we talk about engaging in conservation or thinking about endangered species, we tend to focus at, like I said, the species level. And that's because the species can be a really good indicator of the health of a particular ecosystem, a particular location, or even a broader place, depending upon their range. Now, here on the Central Coast, there's actually quite a few endangered species. There is the southern sea otter, the Morro Bay kangaroo rat. We have several types of fish like steelhead that come here that are all endangered species. There's also coastal rainbow. Oh, those are steelhead. The puma, or the mountain lion, is also an endangered species here. The Choro snail is also endangered. Actually, it's been moved from endangered to threatened status. Why do we care about a snail? Because it is an important food source to a lot of species. We also have a host of birds that are on the endangered species list as well. And we can use these species as a way to check whether or not the natural ecosystem is still intact and make our conservation efforts around that. So if you're thinking about a larger predator species like a mountain lion, you need to not just think about how many mountain lions are in an area and how capable are they of breeding, but you also need to think about what is the food situation like, right? Like that food web becomes very important when we have top predator species as our target endangered species, because it's not just whether that species is okay, it's whether or not they have enough food, or do they have enough water, do they have enough range that isn't overly encroaching on humans that may not want them there. I know here in SLO, we over the past couple of years has had a few mountain lion issues. And that's because our mountain lion population is starting to recover, which is great because that means some of our ecosystems are doing well, but it also means that they need more range. And that means that they are encroaching into places like San Luis Obispo. And so that's part of how we're looking at species. And then finally, an ecosystem is all of the living and non-living organisms that interact with each other and we're interested in the tropic interaction. That's kind of this energy transfer. We consider that the web of life. from predator to prey. And in order to have functioning life, we need to have functioning ecosystems. And so, like I said, we use species as indicators of ecosystem health. And ecosystems, we also want great biodiversity. We don't want narrowing biodiversity. So how we choose to look at things, how we choose to engage in policy, is really important, because our value systems around the environment impact how we see the environment. So your value systems impact your behavior, and how we see the natural resources is really dictated by one of three, can be overlapping-ish ways, but usually we bucket value systems into these three chunks. So there's the instrumental value system. We call this the anthropocentric value system. And this is looking at how the ecosystem is valuable to humans. So humans are in the triangle. They're over here. This is anthropocentrism. And dominantly, we've had men at the top of these systems for quite some time. Globally, we tend to have a system that values males over everybody else, everything else. And then the next level tends to be things that are close to us, right? So family, our pets, money, fuel, wealth, technologies. And then the next level is our food system, right? So when we think in terms of the things that we put instrumental value on, is our food, and then kind of everything else. And this everything else really depends upon what we're thinking about, right? So most people are cool with saving the elephants and things like that. They are not exactly excited about saving the California salamander or the yellow-legged frog. So then that's because we don't put as much value on frogs and salamanders as we do elephants. And that's why the elephants are the big attraction at the zoo. And there's a reptile room somewhere, but it's got everybody else kind of smashed together. It's not like the big attractive exhibit. And that's because of where we choose to place our value. So in an anthropocentric or instrumental value system, the importance of things on the planet is based on whether or not humans find them useful. Then we have an intrinsic or biocentric view. This is also a cosmocentrist view. Things are valuable for their own sake. So this is a species level view. The idea that each species has an inherent right to exist, and they are valuable whether or not humans have a use for them or not. But this leaves out a whole lot of other things that are important to an ecosystem, because it's focusing on the biology, it's focusing on what's alive, and often it's focusing on what we can see. So the trees and the bushes and the mountain lions, and yes, even the frogs might be important, but what about the fungus and the bacteria and the rocks and the rivers? How important are they to us? And that's where an ecocentric view comes in. This focuses on the entire ecosystem as an important value. So the preservation of functional, intact ecosystems as best as that can be in this day and age, and looks at the holistic ecosystem, not just its components. And this is where we start to get arguments around the rights of nature, and the idea of the rights of water, right? So there's a whole water rights movement and the rights of water to exist, and not just exist because we find it useful, but it has a right to exist in and of itself. So our value systems impact the policies and the behaviors that we're going to be engaging in when we think through how we're engaging with nature. Now, when we think through nature, we're going to kind of get into forests right now, but how we engage with forests is going to depend upon where our value systems are, what we value, and how we value them. And that's going to be reflected in a lot of policy. So in a forest, when we talk about forests, we usually need to distinguish between woods and forests. Most people use these ideas interchangeably, but they are not quite the same. So a forest is a thick growth of trees and underbrush covering an extensive tract of land. We usually say that there's about 60% of canopy cover. So this is when you look up at the sky, if you have about 60% of the sky covered up by the tree canopy, you're in a forest. That 60, by the way, it is a guesstimate, right? Like it's not a hard stop. If you have 58% coverage, probably leaning towards forest, not quite as woodsy. So that point is not like this hard sign. So then we usually, when we talk about forests, we talk about tropical and temperate forests, especially rainforests. So there's a lot of there has been in the past a lot of rainforests on this planet. That has been diminished significantly over the years. But usually we're talking about tropical rainforests, which tend to be in warmer climates near the equator, and temperate rainforests, which are usually north of the equator. So when we think of woods, it's a thick grove of trees where you have only between 25 and 60% of a wood is covered by tree canopy. So if you ever are driving between actually north or south, so if you're on 101 and you're driving north or south of here, if you get north, you get near Camp Roberts. That's a good example of woods. As you go south, you get past Santa Maria, in between like Santa Maria and Santa Barbara. There's lots of good examples of woods in those areas. Those trees are more spaced out. Those are all coastal live oak, by the way, with some manzanita. There's some other trees, but they tend to be, this area tends to be coastal live oak dominant, but you can see how you've got those woods spread out a bit more. So it's important to understand the difference between a forest and a woods. Now, where do we find these things? We find them all over the place. Remember I said tropical rainforests tend to be around the equator. Here is the equator. Right here is where we're seeing our tropical forests. So this dark green, bright green, and yellow are all types of tropical forest. And you can see they're very much around the equator. As we start to move away from the equator, and keep in mind that Central America and the Caribbean are also pretty humid places, as we start to get away, we have this band of what we call subtropical forests. It's kind of on this line here. And then as we get up towards Oregon and north, we start to get into the temperate forests. And then as we go even farther north, we get to the subfrigid coniferous forests. So up here in Canada, this is where we get our coniferous, we tend to get our coniferous forests. This is also where we had a ton of fires this year. If you heard about the fires up in Canada in the spring of 2023, this is where a lot of that is occurring. Right now, we're seeing actually a lot of fires down here in South America. This is fall of 2023. They have had the warmest winter on record. Some places are 40 to 50 degrees hotter than normal for their winter. And they're having intense fires because they are drying out, that we don't usually see in these tropical and subtropical forests because of how much humidity normally is in these places, and that reduces the odds of fire. It's not that fire doesn't occur there, but it doesn't occur as frequently as it does in other places. So what do forests do for us? Why should we care about forests? Forests do a ton of things for humans. So they do a lot in terms of habitat for wildlife. And again, if you're thinking of the different value systems, if it's just about what's important for humans, we might not care as much about wildlife. But if we're thinking about what's important for the ecosystems, wildlife is absolutely important. Also, we are finding more and more often that when we have healthy biomes, we as humans actually end up with cleaner water and less soil erosion and things like that. Forests are huge in terms of filtration systems for air and water. They help keep the rain, the water that comes down through rain on the ground. It tends to help with water absorption. It acts as a filtration system. It helps retain snow melt. So forest soil is more likely to freeze less deeply, so it's able to absorb more water from melting snow, which of course helps extend out the runoff period. And as a state that tends to be focused on snow runoff as opposed to rain as our primary water source, forests are very important for this. They also help with climate control. So crowns of trees hold a lot of moisture in and helps to keep the forests cool in the summer and warmer in the winter. Trees tend to block the heat from the sun. The heat absorbed through the transpiration process also cools the air in the immediate vicinity, which is why urban forestry is becoming more and more important, especially as we have hotter temperatures in cities. Using urban forestry as a means of cooling off cities is becoming more and more important. They also help reduce the glare and reflection off high reflective surfaces like concrete and glass, which also cut down on how hot cities are. They help reduce soil erosion. So when you have healthy forest systems, that tends to keep the soil in place. When we don't have healthy forest systems, or we have a place where a stand killing fire has come through, we tend to have a lot more soil erosion. That soil erosion ends up getting into our creeks and streams and rivers, and that actually blocks them up. And as that gets down to where those rivers are going into the ocean, we have a lot more sediment deposits when you have higher soil erosion upstream. And that has a lot of effects on ports, harbors, anywhere like that we're seeing that's important for us. So keeping that soil where it belongs underneath those trees are really important. They also are important for flood prevention. Of course, forests are great places for recreation, and we still have a lot of demand for wood products. So forests provide our wood products. And of course, they are a great place to help reduce greenhouse gases. Forests can be an important carbon sequestration place, depending upon what's going on with that forest. So when we think through forests, we're usually describing how these ecosystems work together. Keep in mind, forests aren't just trees. There's lots of other components to forests that have a really important effect for us. So when we think through these landscapes, we usually use some important terms for landscape ecology. So landscapes are living systems that have three broad characteristics: structure, function, and change. So when we think through how landscapes work, we talk about the spatial patterns or arrangements of the landscape elements. So where are the trees? Where are the creeks? Where are the boulders? Where are the streams? How are things put together? That's the structure. The function is how things move through that structure. So this can be plants, animals, water, wind, materials, energies. When we think of the web of life, the nutrient cycles, that's around the function. And then also landscape change. So all landscapes are dynamic. They are not stagnant. They don't just stay the way they are forever. They change over time. And so understanding the dynamics of spatial patterns and functions over time is what we call landscape change. This is also important for us to understand if we're going to make policies around conservation. Is how are these landscapes structured? How are they functioning? How well are they functioning? And how should they be functioning? And what sorts of changes should we expect in the landscape over time? So the other thing that we talk about is energy and nutrient cycles. So part of the forest dynamics is how, like I said, things function. So that is how the physical and biological forces that shape and change a forest, and understanding those. The energy flows and nutrient cycles occur within the food chain or food web. You guys have all heard about the food web, probably in like second grade science class. Well, the food web is just as important here. One of the things that we know is, and we're starting to expand our knowledge about, is not just this above ground system, which we've spent most of our research has been on these above ground systems, but now we're delving into how these below ground systems are coming into play as well. So this is all your soil scientists and your microbiologists and your mycologists are going to be looking down here, because we know that what's going on in the soil is just as important as what's going on above the soil. So these nutrient cycles work together in important ways. So here you have the leaves falling down. Wildlife will eat the leaves. They will eat the debris on the ground, but they're also pooping and peeing, which is adding plant and animal matter into the decay process. As that decay process starts, you get decomposers breaking down this organic matter. That becomes food and minerals and nutrients, which are released into the soil, which helps plant growth. And of course, water and air penetrate the soil. That helps this process as well. So this is a very dynamic and complicated system. So understanding how these cycles come together also helps us understand how these systems need to be functioning. The other thing that we talk about is disturbance and succession. All ecosystems need some disturbance. All ecosystems change over time. So this idea that we need to have these stagnant ecosystems is wrong. And of course, we usually talk in terms of disturbance and succession. So disturbance is an event that causes changes in forest structures and compositions, resource availability, and the physical environment. Forest disturbance vary in type, frequency, scale, severity. Some examples include fire, wind, insects, disease, flooding, ice storms, overgrazing, timber harvesting, construction, and conversion to non-forest are all examples of different types of disturbance. Now, how impactful that disturbance is, we usually talk in terms of stability, resilience, and threshold. So stability is the degree to which an ecosystem's long-standing composition and structure can be subjected to disturbance and maintain their characteristic components, structures, and processes. So if you have a bad windstorm and the windstorm knocks down a number of trees, but you still have a whole bunch of trees left, the forest is probably still pretty stable. If you have a stand-killing fire, you do not have stability anymore. That composition and characteristics have been radically changed. So resilience is the ability of an ecosystem to recover to its pre-disturbed state. Now that's really important, as opposed to the idea of adaptation, which is becoming something else. So resilience is the ability to return to its pre-disturbed state within a reasonable period of time. There is some questions as we have increased climate change about returning to a pre-disturbed state, whether or not that is realistic for ecosystems, or do they need to engage in succession into something else? And the threshold is the limits to change or disturbance, which if surpassed will result in a fundamentally different ecosystem. We call these tipping points. How much disturbance can an ecosystem tolerate before it needs to become something else? And we call that something else process succession. So this is ecosystems generally develop gradually and change over time in their components, structures, processes, and their functions through a variety of different processes. usually we call these primary and secondary successions. So primary succession is the initial establishment and development of an ecosystem in a previously abiotic environment. So if you're converting the desert into a forest, that would be primary succession. Now, the desert, by the way, is not abiotic. There's plenty of things that live there. Secondary succession, though, is the development of communities on organic substrates created by natural disturbances. And each stage builds upon itself. So when we think through these stages, we often think of starting out as kind of nothingness and then getting maybe some fungus or lichens or things like that, and then eventually progressing into forests as kind of like peak ecosystem. But that's not true. Peak ecosystem is the ecosystem that is most viable for that particular location. Not everywhere should be a forest. We still need lots of grasslands and tundras and deserts. Those are all also important ecosystems. So this idea that this succession process should be the norm from nothingness into forests is just not realistic, although we still get some of that in some textbooks. Now, one of the things that we have seen from humans, this is a very human thing to do, is the fragmentation of ecosystems. And we don't see other species doing this because we don't see other species changing the way that the ecosystem functions in the way that we do. So when we talk about ecosystems, isolation and fragment, we usually start with fragmentation. So this is where you're breaking up larger intact habitat into smaller dispersed patches. This is a good example where they're doing clear cutting out here. Obviously, this was a big tree. So now we've carved out this new ecosystem, this post-harvest ecosystem. You can see that there is intact forest for right now in the background of this picture. We have a tendency when we're doing forestry to clear cut and then jump over a bit and clear cut again, and then jump over another bit and clear cut again, as opposed to just cutting everything down all in a row. And that is an example of fragmentation. So dissection is splitting an intact ecosystem into two patches separated by a corridor. Best example of this is roads, particularly highways. Highway 101 is a great example of dissecting chaparral and oak manzanita habitats and basically separating them into two parts. And for animals to go to the other part has a high degree of risk for them. And that's why we have so much roadkill. One of the ways that we're actually working on dealing with this dissection by roads is creating animal corridors. And we'll talk about that in a couple slides. Perforation is kind of creating holes within an intact habitat. And then shrinkage, of course, is shrinking the size of one or more habitats. And attrition is disappearance of one or more patches altogether, like they just go away. So you might have dissection by two patches, and then we build buildings on them, and those patches are gone. Those ecosystems no longer exist. I'm going to go to the next slide because it actually gives you a visual of this. So this gives you a good example of the difference between a patch and a corridor and a mosaic. So here we have this large ecosystem. At one time, it was all forests, right? This was obviously a forested ecosystem with a river system going through here. So what we've done is we've created a number of individual forest patches. You can see them here. But that's what they are. They're patches. Now, how these patches were created, probably has a lot to do with how these farms, these are all farms out here, were developed. It is very possible that someone first put a farm here, actually probably going to put the farm here because it's by this river, and all the rest of this was forest land. Then maybe you stuck another one here and then another one up here. So you're perforating this system until eventually you just have patches of these forests. And this is a good example of kind of how we think through the decline, the loss, and the isolation. Now you've got critters in this forest here that are pretty isolated. They have to be able to get over to these other patches in order to find mates or, get to water or things like that. So this patching can be great if you're talking about the creation of farms, but not necessarily great if you're talking about the needs of wildlife. There's definitely opportunities to create corridors that connect these patches that make things easier for wildlife to get from point A to point B, which brings us to our next slide of corridor. These are two dramatically different types of corridors. So this is a wildlife bridge. We have several proposed to go over Highway 101, up and down California. We have done enough research to know that if we offer corridors, wildlife will use them as opposed to trying getting across the road, as long as they're reasonably close together. So the other example is creating these corridors for wildlife in a clear-cut situation. So you can see they've left some corridors, they've put in a bunch of roads, they've clear-cut all of these areas. They'll probably replant them. That's a whole other lecture, but you can see they've created corridors for wildlife to be able to go on here. So what does forest look like on Earth? It's changed over time. I showed you that map a few slides ago of where we have different types of forests. So on planet Earth, it's only 29% land, it's 71% ocean. So we're going to work within this land, this 29% land, to talk about this. So there's about just under 15 billion hectares of land. And before we start doing a lot of things with the land, about 71% of it is habitable. 19% is barren. So this includes deserts, salt flats, rocks, and dunes. And then about 10% were glaciers. Humans did not inhabit a lot of these areas because it's much harder to live in these areas when, of course, you have 71% that's habitable. So 10,000 years ago, before now, about 57% of this habitable land was forests, and 42% was wild grasslands and shrubs. And then we have like 1% that's freshwater, not a ton. So in a 5,000 year period, we see some decline of forests and some expansion of grasslands. And our freshwater, by the way, stays pretty constant. Then we start farming, right? Like we start having a lot of population growth. We start engaging in more intensive farming. We start to also have a lot of technologies that have a lot of demand for forest products, particularly wood. So as we start to see the Iron Age, as we start to see the Bronze Age, we start to see the creation of glass creation and pottery. These all have impacts on demand of forest products. So starting in the 1700s, about 52%, so we're down about 5% of the land is forest, 3% is crops, 6% is being used in grazing, and we can see that we've cut back on our wild grasslands and shrublands. Within 100 years, we've expanded that out more, especially for grazing. Mostly that's happening in grasslands. In the 1900s, we see a huge hit towards forests. We have about 48%, but half of forest loss occurred before 1900. We see the expansion of croplands, grazing, and the serious decline of shrublands. In the 1950s, we've got 44% of forests. Once again, a lot more crop and grazing. We have pushed back those wild grasslands and shrublands, kind of stays where it is. Crops and grazing is now cutting into forests significantly. And of course, we start this prospect of urban buildup. So this gives you a feel of where we're using the landscape that we have and kind of where we've seen the decline of forests and we've seen the decline of wild grasslands and shrubs. So what is the current state of our forests? So here in the United States, we have about 881 species of trees, but less than 300 of those are endemic to the United States. So we have lots of invasive species that have come here and do really well because we have good climate for growing lots of trees, and we've brought in a lot of trees. Many of the ornamental trees that people have in their yards are all invasives. Right now, approximately 11 to 16% of all of our endemic species are threatened with extinction. Globally, about 34% of all conifer species are under threat. There's a great website we're going to look at really quick called Global Forest Watch. If you are doing anything around forestry, decline in forests, etc., Forest Watch, Global Forest Watch is a great resource. So we can look at the change. So this is tree cover loss. Blue is gains. Notice there's no blue. We can actually watch this video where you see the percentage of loss since 2000. So that gives you a good feel of what's going on with that. There's lots of different types of options you can have here. You can look at logging, you can look at protected areas, you can look at tree density, carbon soil density, you can look at biodiversity. So this has lots of options if you're doing research projects to look at forest diversity and ecosystem diversity. Other good resources are the Red List. So the Red List, you can search for tree species. These are the endangered species. And it tells you here about the tree and what it does, where it's listed, where it is it stable, is it decreasing? You can look by location, you can look by type of tree. I don't know why I have tree snakes up here. Let's see. So, oh, not pineapple, pine trees. So we can look at all the different types of pine, right? Shoreleaf pine. There's just tons of different pine species that are out here that we can look at. The one that I work with, it's the Monterey pine species. I could only spell the word Monterey correctly. So here is the Monterey pine. It's decreasing, it's endangered. Just so you know, it's only natural locations. Whoops, didn't mean to blow you up that big. Its only natural locations are actually here in North America. And its range is this area here. There's a little bit above up here that the Swanton Pacific Ranch is actually the northernmost stand of this particular tree, but this tells you a whole lot. Tells you it's endangered, when it was last assessed. It definitely needs updating. Talks about severely fragmented populations. There are only 5 native stands, 2 in the Channel Islands, 1 in Cambria, 1 in Monterey, and 1 up in Davenport. So you can see all the things that are there to learn about this particular, to learn about the red list. And then there is a great paper called The State of Trees that they turned into a website. And again, this talks about which trees, conservation paths, how you want to think through this process. So this is the Morton Arboretum who did this assessment. So if you want to delve more into the state of forests globally or locally, these are great resources. Now we have a number of our forests that are actually protected. And so this is a map of our federally protected forests. I know this looks old-timey, and it is, but it hasn't changed. So you can see all of these green areas are national forests. There's other lands in here that have forests on them that are not on this map, because these are just our national forests that are part of the Bureau of Land Management or other sorts of areas. You can also see our national grasslands. Keep in mind, all of this was a grassland, like this whole thing was a grassland. You can see a lot of the areas that are protected are areas that don't actually have huge populations. They're actually hard to get to or live in. So this is where our national parks are. And yes, conservation is important, but it's also important to note that timber is incredibly important in terms of human survival. Humans have always used timber for fuels. They use it for housing. They use it as materials to do other types of building, to build furniture and houses and a whole bunch of things. And so conservation needs to be balanced and can be balanced. And I think that is important and something that we're starting to see happen more, particularly in the timber industry, is thinking through how do we engage in responsible harvesting in a way that's financially viable, right? And how do we think differently through the use of timber products? There are 490 million acres of timberland in the United States alone, and there's about 1.6 million people that work in the forest industry. So this is people who are foresters, people who are engaging in logging and all the parts of the practices that go along with logging. It's a complicated operation. We actually have several classes here at Cal Poly that talk about logging as the primary focus of the class. It is a huge revenue generator, about $34 billion a year. And we also import almost 4 billion cubic feet of wood from around the world. So we're not just using the wood that we have here in the US, we're also importing a lot of wood. The timber industry is actually one of the main drivers of how we ended up with our forest fire policies that we still have to some degree today. The idea was to protect the forest at all cost in order to ensure harvesting. And this meant that the forest department had a policy of all fires must be out by 10 a.m. the next day. So that fire suppression policy was driven by the timber industry's desire to be able to harvest wood. And forest burning down does not help with wood harvest. So fire suppression became the policy of the land because we had a very anthropocentric view of what forests were for. They were for humans to harvest timber from. That view has shifted over time to a more holistic view or ecocentric view to some degree. We're starting to see policy shifts around that. But there is a way to have a balance, right? This doesn't have to be all or nothing. There is a way to have a balance between our need for wood products, which still exists, and our need for healthy forest ecosystems, because we have a need for both, especially in the face of climate change. So climate change is having a huge impact on our forest systems. We need forests as one of our primary carbon capture resources. Now, 55% of the carbon stored in trees is above ground. So that's important to think about, because if you have a forest fire and you've made your carbon capture in a forest, most of that carbon gets released. So this can be very vulnerable to fires, logging. The Global Forest Watch had a study that they did that showed letting forests regrow naturally has the potential to absorb around 9 billion metric tons of carbon dioxide from the atmosphere each year. And this is also while still maintaining grasslands and the current level of food production. So this is possible. That would be the equivalent of soaking up about 23% of the global CO2 emissions every year. Now, forest capture and storage stores different amounts of carbons at different speeds, depending upon the nature of the stand, how balanced it is. Uneven age stands tend to offer the best carbon capture solutions. So you want some young trees, some middle-aged trees, some old growth trees in order to have that balance. And of course, you want to have that balance because not every sapling is going to make it. In fact, when we have clear cuts and we try to regrow forests there, we have a very low survivability rate, despite all the interventions we've tried to do. Middle-aged trees tend to grow a bit slower, but they're more established, so they're more likely to continue to make it. But the amount of carbon that they capture and store can be greater compared to the smaller trees. And of course, old growth forests that have more mixed or less dynamic carbon cycling within the live and dead trees in the soils. But old growth forests tend to be where we sink most of that carbon. Climate changes is severely impacting all forests across the globe, especially through changes in tolerable temperatures and water resources. Trees are not ants. They can't just pull up their roots and walk to an appropriate temperature for themselves and their children. So they're stuck where they are. We are seeing forest migration, not in an ant way, but we do see trees moving up that are usually in lower elevations, starting to move to upper elevations. And we're seeing trees, if in the northern hemisphere, trying to move farther north, and the trees in the southern hemisphere is trying to move farther south to find temperatures that is tolerable for them. So we need to see more than just the trees. We also need to see the complexities of these ecosystems and understand how those complexities help those trees survive. So I'm actually going to post these two videos. I'd like you to watch them. Some of you have seen the wolves in Yellowstone, and that is a really good example of how different species being reintroduced can have a profound effect on ecosystem stability. And then beavers as ecosystem restorers and fire prevention. As we're starting to see the reintroduction of beavers into ecosystems, we are seeing pretty dramatic impacts on those ecosystems and how well they can deal with fire. We're going to start talking a little bit about fire in forests. Most forests have fires. Fire is not bad for a forest. Matter of fact, fire can be a very, very important thing for forests, especially if they're fire adapted. This is the historic fire frequency map. You can see how often fire goes on the landscape. So these darker red areas tend to have fire more often. And then the darker you go into the purples here in the Southwest, this is the Mojave Desert. It doesn't get a lot of fire because it doesn't have a lot to burn. So you can kind of see how these fire regimes come into play. It should be noted that, even up in New England has a fire return of every 20 to 40 years. And this is heavily forested area. These areas historically get fires. So the idea that we can't have fire anywhere or fire is a bad thing is really not healthy for our ecosystems, but it's finding a balance. So we're going to focus on one particular ecosystem. We're going to focus on the Bitterroot Mountains, particularly Bitterroot National Forest. So this is going to kind of be our example of fire and ecosystem management. This is home to the Bitterroot Salish Indians. This goes from chunks into Montana. Most of this is, chunk of it is in Montana, a chunk of it is in Idaho. This is a national forest, and the reason why I chose a national forest is because the national forest, regardless of which state you're in, is run by the federal government, and so the policies that are going to be in place are going to be around national policies, so we don't have state-to-state differences. This is a ponderosa pine Douglas fir dominated forest. We also know that there are lodgepole pines and larches in this area. The average fire return is every 7 to 20 years, depending upon elevation. It has a pretty long history. Well, it has a 200-year history of Western expansion into this area. So this area was part of the Lewis and Clark expedition. We know that they passed through there in 1805. In the 1860s, during the gold rush, gold was actually found in Montana and Idaho. And so we have a number of mining towns that start to crop up, a lot of which are ghost towns today. We also know these areas have been subjected to heavy logging and other resource depletions beginning in the 1880s. And this eventually led to conservation. So there are conservation efforts that have gone on in this area. So in 1907, the Bitterroot Forest Reserve became a national forest and came under the purview of the Forest Service. Now, the Bitterroot National Forest has experienced a number of fires, the most historic of which was in 2000. I actually had the experience of driving through the Bitterroot National Forest fire. I was in the process of moving, and my partner's family is in Montana. We were coming up from California to go visit them, and there was a pretty significant fire going on. And you can see kind of part of the road up to Missoula. And this whole area here was where the fire was. And actually, I got to watch the fire burst over the ridge into the valley where the road was that I was driving. Pro tip, if the fire is coming right for you, you should go. So the fire destroyed 70 homes, 2 commercial properties. Much of the burning occurred in the low elevation, warm, dry ponderosa pine type forest, which tends to occur along the wildland urban interface. This forest fire was driven by high fuel loads. It was also pretty dry, so we had a lot of drying out. We also had an increase of insects coming into the area that also killed off a lot of the forest. And so we had a lot of buildup. And as a result of the fire, actually, we've seen an increase in fuel loads because of the fire-killed trees that are falling over and accumulating on the forest floor, which means that you might actually end up getting worse fire in this area. So we're going to this is up in this area. We're going to kind of do a time-lapse series. These pictures were taken up in the Bitterroots and gives you a good feel of, in 1909, this is the forest. This is what it looked like when it became a national forest. So this was in 1909. Now, we have fire suppression. We watched the video on the big burn. Fire suppression kicks in, right? We don't want fire. We want to put fire up pretty quick. Well, fires are supposed to be returning every 7 to 20 years. This is in 1925. So you can see all these little baby trees starting to build up, the brush and everything like that. You have some trees that are decaying. So we're getting into a point where normally there would be a fire to come through and clean this out, but we don't allow that fire. So here's in 1938. You can see this build up even more. Here's 1948. You can almost not see any of what we had already seen. You can see those trees from a few decades ago are getting taller. The older trees are getting weaker. We have more grasses coming in, a lot more fine fuels coming in. This is in 1958. You can see even more. You see a lot more debris on the ground. All of this is fuels. Same place in 1968. Doesn't look anything like it did back in 1909. And here's 1979. You can see this forest has built up a lot. There's tons of fine fuels. There is no distance between the bottom of these trees and this fuel load. So if we get a grass fire coming through here, it's going to go right up into the canopy. Now we have some thinning, and we have a prescribed burn that we brought through this area. And this is like the year after that, a couple of years after that. And you can see that we now have a separation of what's going on in the grasses. We have a lot more distance between these trees. That distance is important because if they're too crowded, fire spreads even more. So fire is an important clearing out tool for forests. And fire can be used as a tool in forest restoration. Fire works on a scale that would take humans a lot of time and resources. This is actually up in Yosemite. There was a fire that went through there maybe 5 years ago. And I want you to look at how open this space is. This is only 5 years after a fire. This is really open. It helps remove dead trees. It increases canopy openings to allow sunlight to the forest floor. It thins out tree cover to create more meadows and woods, which allows for different species to grow down here. It increases resources for the trees that made it. They're not competing as much with other trees for limited resources like water and soil nutrients. And also, like, these are pines. Pine trees are dependent upon fire in order to open up seeds. And so regeneration is really important and triggered by fire. So for ecosystems where fire is normal, the forest actually does better after a fire. And we can see that here. So we're going to watch a very short video on fire recovery.
Very similar to this has been playing out across Colorado the past few weeks as some 2,000 acres of forest land have burned. But this video is from 2012, the big High Park fire up in Larimer County. As we now wonder what will become of the recently burned out areas, I talked with an expert about the resilience of nature.
So we're looking at the west side of the High Park fire off in the distance.
Boyd Labita of the Colorado State Forest Service had a front row seat to the inferno as he helped marshal resources during that High Park fire.
Is it tough to watch?
Well, in a sense it is, but in a sense also it's the natural process of these forests.
And at the time, the results were stark.
This forest we're standing in, all the trees were killed right here.
But you won't see this longtime forester feeling sorry in the aftermath. For the person who was killed and the 259 homes lost, absolutely. But not for the forest consumed in the burn scar that stretched up to 20 miles.
The forest is a fire-adapted ecosystem. It has burned before. It's going to recover.
Aspen trees are the big winner after a wildfire. When the mature ones burn out, it stimulates the root system to sprout new aspen. Wildflowers and shrubs, once choked out by the tree shade, are thriving in the sun.
We know what the density of our forest was before the fire.
The acreage we walked is managed by CSU foresters. The lodgepole and ponderosa pines coming up are a combination of plantings and natural regrowth. This young tree provides a positive sign.
This year's growth is already probably 4 times what last year's was. So that means the tree's getting established. It's got a root system going.
That means there's been enough moisture. But our new warmer, drier weather patterns likely mean the next forest will be noticeably different than the last. 6 years ago this summer, this hillside was on fire. And afterwards, because that terrain is so steep, it was impossible for crews to get up there and physically plant seedlings. Well, we know it'll take years for the pine and fir trees to regrow. But in the meantime, the wild grasses and shrubs have really taken off. We all know wildfires will always be part of Colorado. And those burned lands will always be reborn.
The High Park burn area was hit with major flooding and back-to
But I think it's important to remember that these areas do recover. That video also gives us a great example of succession, right? We had a fire. That fire was a stand killing fire. It killed off a lot of the trees. That opened up the canopy. And now we've got grasses and flowers coming in. We still have trees recovering. We still have those pines that are coming in. But we have all of these wildflowers that are suddenly able to come into this area as well, that weren't necessarily able to be there before. So fire is an important part of forests and forestry, and understanding how forestry and fires go together is part of what we need to keep in mind, especially as we have more people deciding to live out into forests. And we need our forest ecosystems to be healthy. We need them to be able to do what they need to do to be able to be sustainable. We know that they're going to be impacted by climate change, and that can be really hard for us to start to process on that, how that's going to impact things. I do have another video that I'm going to have you watch on ghost forests that kind of help us understand that migration process. And that's it for forests. I hope you guys had a great understanding of forests now. Thank you.